Hello and welcome. In this video, we're going to be talking about how to subtract rational expressions. So our first step in the process of subtracting these two rational expressions is, just like when we're subtracting fractions, we have to find a common denominator, which really boils down to finding a multiple of both of our denominators. So our first step is going to be to find a least common multiple of both of our denominators. So if I just pull our denominators aside, I've got 6a to the third, c to the third, and then I've got 4bc. And now if I factor 6, that factors down into 2 to the first times 3 to the first, and then I've got a to the third times c to the third. If I factor 4, 4 factors into 2 times 2, or another way to say that is 2 squared times b times c. So the least common multiple, remember, has to have all of the factors in either one of my two denominators, and it's going to have the highest power of any factor they have in common. So one of the factors that I notice is that they both have a 2 factor. So I've got a 2 to the first here, a 2 to the second here, which means my least common multiple has to have a 2 squared in it. It has to take the highest power of any common factor. What are some other factors? Well, it's got to have a 3 in it. It's got to have an a cubed. Now I see another common factor of c, so I've got c to the third here, and I've got c to the first here. Again, I take the highest power, which is c to the third. And then the only other factor I see is b, and my highest power there is b to the first. So my least common multiple is going to look like that. So now that we found our least common denominator, which is this 2 squared times 3 times a to the third times c to the third times b, I want to get this least common denominator as the denominator for each of my original rational expressions. So what I need to figure out is what each of the denominators is missing from my least common denominator. So if we look at the first guy, you'll notice that I've got the 2, but my least common denominator has a 2 squared in it. So that means I'm missing a factor of 2. So what I'm going to do is multiply top and bottom by 2. Okay, the reason I have to multiply top and bottom by 2 is I don't want to change the value of my original fraction. So whatever I multiply the bottom by, I got to do the top because it's really like multiplying by 1. So when I look at the least common denominator versus my fraction, the only other factor that is missing, the only other factor that's missing is this b factor. So it looks like I've got all the a factors that I need, I've got all the c factors that I need, the only factor that's missing is this b guy. So again, I'm going to multiply top and bottom by b. Okay, if I do that, my new fraction, whose value again hasn't changed, is going to look like this. Well, on the bottom, I'm going to have 2 squared times 3 times a to the third times c to the third times b, and that again it matches my least common denominator, so I know I've met my goal. On the top, if I multiply those two terms together, I'm going to end up with 5 times 2 is 10, and then I like to put my variables generally in alphabetical order, although I didn't do that on the bottom. So I'm going to have b times u to the third on top. So my first fraction is exactly in the form that I want it to be in. The second fraction, I want to get that least common denominator. So again, what I'm going for is I want to get this denominator down here. So again, I'm going to play the what's missing game. When I look at the least common denominator versus my denominator, one of the factors I see up here is it's got a 3 factor, and my guy doesn't have a 3. So I'm going to multiply top and bottom of this fraction by 3, and then One of the other factors that I see is this guy has an a to the third. My guy doesn't have any a's. So that means I'm going to multiply top and bottom by a to the third. And then you'll notice that my fraction does have a c on the bottom. But what I need is c to the third. So I'm missing two factors of c. So I'm going to multiply top and bottom by c squared. And I think that will do it. So now if I multiply my bottoms together, I'm going to end up with 2 squared times 3 times a to the third times c to the third, because when I multiply c squared by c to the first, I add those exponents, become c to the third, and then times b at the end. On top, if I multiply my terms on top together, I've got 3, and now I've got a to the first times a to the third. Again, I'm going to add those exponents. That becomes a to the fourth. And then I've got c squared and then w to the third. So the final step in the process is just to subtract the two fractions that now have a common denominator. So just imagine that I'm subtracting something like 4 over 5 minus 3 over 5. When we subtract two fractions, if their denominator is the same, my answer is going to have a denominator that matches whatever the common denominator is, and then I'm just going to subtract the two numerators together. So we end up, in this case, with 1 over 5. So here, we're going to do something really similar. Our third and final step is just to subtract the numerators, and then our answer is going to have the common denominator as its denominator. So step 3 is we're just going to combine into one fraction. So I know that our denominator is just going to end up being 2 squared times 3 times a to the third times c to the third times b. And then I'm just going to subtract my two tops. Unfortunately, though, when I look at the tops, they're not like terms. So you can see that this guy has a b and a u to the third, and this guy, when I look at its variable parts, has an a to the fourth, c squared, w to the third. So those aren't like terms. There's no like units there. So what we're going to do is just leave them separate. So the top is just going to look like this. I'm going to have 10b u to the third minus 3a to the fourth c squared w to the third. So my final answer, the only thing I'd want to do now is just clean up the bottom a little bit. So in ALEKS, what we want to do is just make sure that we have the bottom kind of multiplied out so that we end up with a single coefficient. So 2 squared is 4 times 3. I'm just multiplying these two guys together. So 2 squared is 4 times 3 is 12. And then I am going to go ahead and just put my variables in alphabetical order. So I've got 12, a to the third, and then I'm going to do my b next, and then c to the third. On top, I'm just going to leave it as it is. So 10b u to the third minus 3a to the fourth c squared w to the third.